Welcome. This is question 16 from the geometry practice test for TNReady. This is a calculator allowed section. In the figure shown, triangle RST is similar to, so if you see this symbol here, that would be similar to. What does similar mean? Similar means that corresponding angles are congruent, so because they give us the statement, I know that angle R, it goes in the same place, so R is the first letter. And angle U have the same measure. So TRS and WUV, that angle here and here are the same. Also, corresponding sides are proportional, not congruent, they're proportional, so you can create a proportion. So the relationship between RS, so if we're doing a ratio of this first triangle here, so RS over ST, I can make that equal to a proportion, or ratio, created by this side, so UV over VW. As long as you have your corresponding sides in the same spot, any ratio should make this proportion true. So there you go. Congruent angles, proportional sides. Now, it's triangle RST is similar to UVW. Write an expression in terms of M and P that represents the tangent of R. Now, the tangent of R, in a right triangle, we're talking about the relationship between opposite sides and adjacent. So whatever you do to remember that, you may use SOHCAHTOA. This would be the TOA. When I was in school, we did the old aardvark sat on Henry's coat and hat, and I could always visualize that little aardvark crawling up on the hat there and the coat. So the old aardvark taught me this. Now, if I want to do the tangent of R, I need to go to this side, that'd be the opposite side, and the adjacent side would be down here. It's the other one. The one across from the right angle, of course, is the hypotenuse. So basically we're looking at other. So the tangent of R that I'm trying to create is equal to, and we'll just name them by the sides, ST over RT. And I'm going to put this over here as my ultimate goal. I want to make ST over RT. That's my purpose in this. So from here, you realize very quickly that ST does have a value, so I'm part of the way there. I can put M, go ahead and lay that there, and then deal with RT here in just a second. We have to find it. As you may remember, I said that there are proportional sides in a similar triangle set. So we're going to try to find this value here. We're going to try to find RT. That's our ultimate goal. So I'm going to create a ratio with sides that we actually know the values of. We know RS is N. We know this is 3/2 over N. We know this is 3/4 P. And we know this. So using this M right now doesn't help us to create a proportion to find the value of RT because we don't have what VW is. So I'm going to use this and this side and this side. So for this triangle, my ratio would be N over RT. RT is not a variable, it's just a label. For my other side, the N was the hypotenuse, so the hypotenuse over here is UV, so it's 3 over 2 N. For my adjacent side, I guess, it would be 3/4 P. So I can cross multiply here. I'm ready to cross products, I guess. And this one side would be 3 over 4 P times N. And you could put them together like that, or you could put this in parentheses, whatever you want to do, really. The other side would be 3/2 N, and I'm going to put this one in parentheses because it's a side, times RT. I'm trying to find the value of RT as shown over here, so I'm going to divide both sides by 3/2 N. Cancel that out. But if I do it over here, it's not so nice. Now the n's cancel out nicely, but 3/4 divided by 3 over 2 is not pretty. This is gross. But anybody who's in the 5th or 6th grade that has a teacher who does this will tell you that you don't really divide fraction by fraction. That's not how it works. Instead, keep it, flip it, so you flip the other one, switch it to multiply. And you could do 3 times 2 is 6, 4 times 3 is 12 and reduce, or you could see that there's a 3 in the numerator of this one and the denominator here, and they cancel, and you get 2/4, which reduces to 1/2. That is the value that's left when I do this division, so I end up with 1/2 p, see how this is what's left here, equals the side RT. Still not done. This is a long problem. So now I found our t to be 1/2 p. Again, you can't use the, you can't have fraction in the denominator. You can't have a fraction in a fraction. That doesn't work. So there's a couple ways you can deal with it. We can say this is 1. The first thing you could do is try to eliminate 1/2 by multiplying by 2 and do it to the top and the bottom. Or if you want to stick with the old keep it, flip it, switch it thing that we were doing earlier, that's also fine. So 1 would be kept. This would be switched, and or this would be flipped, and this would be switched. So it becomes 2, and that stays in the denominator, or in the numerator. So 2m over p, because this is 2 over 1, so the 2 would go up here. For this one, the p is outside, but if you wanted to put p on top and make it p over 2, you can totally do that too, either way. So anyway, st is 2m because it was originally m, and then rt was 1/2 p, and then when I worked it out, I end up with a final answer of 2m over p. A little bit weird, but it's mostly about the idea of dividing by fractions more than it is concept. But if you can remember similarity, you can organize your ratios in ways that make sense. And then don't forget, when you originally set it up, find exactly what you're looking for before you move deeper into the other math. That way you're leaving like a little trail of breadcrumbs so you can find your way back to the point where you're putting your answer.